Hello everyone. Well, by now you should have gotten through most of the chapters in the Data Camp course. There are 6 chapters in that course. By the time you get to 5, I think you've covered data frames, and I think the 6th chapter is lists. But the textbook's moving a little faster, and so my job is going to be sort of bridge the gap between what we're covering in the Data Camp modules, Data Camp chapters, and what the textbook is expecting you to know. The textbook has already gone through in the first chapter, certainly in the second chapter, it's gone through the process of loading a data file. And loading a data file, the first time I ever did it in R, was the most frustrating thing because I couldn't get every single thing right. So what I've done is I have filtered this down to what I think is probably the simplest process for loading that data file. And I'm going to walk you through all the things you need to put in place in order to make sure that you can get a data file loaded in R. And then I'm going to show you actually how to do it. Then I want you to try it as well. So anyway, let's start first of all by talking about the how to load a data set. All right, there's 2 ways to load it. You can load it in regular R, or you can load it in RStudio. The only advantage of RStudio over R is that you have the ability to go in and browse for the file, and that will be important in a minute when I talk to you about set working directory and get working directory. In R, the advantage is that you can load the data file directly into the data frame that you want. The way that they do it, they have you loading it directly into housing.df, and that's a small advantage because certainly once you loaded the file into RStudio, which it loads basically with the name that it has on your PC, you can then just dump it into a data frame, and that's fine. So it's easy one way or the other. We're going to load one of the data sets from the textbook. There is a companion site to the textbook called dataminingbook.com, and if you get an account on that, you can see all of the resources that they have, and you can see a lot of good, useful stuff, not the least of which is going to be your data files. I have downloaded westroxbury.csv, which is basically 5,802 records of information about a neighborhood called West Roxbury. So it contains information in 14 columns, and we'll take a look at that file. Like I said, you can load it one of 2 ways, and I'm going to show you how. So let's first of all look at how they load it, the command that they're using actually to load it in the textbook. The first thing they do is they designate a data frame called housing.df, and that data frame takes on the value of the results of a function. The function is read.csv, and then each function in R is fed some number of arguments. In some functions, in some cases, functions can take many arguments. In this particular case, we're only feeding it 2 arguments, and in some cases, as you'll see with get working directory, functions can take 0 arguments and run just fine. But most of the functions, most of the things you do in R are going to actually be driven by functions. And the format of a function is just to put the name of the function with an open paren and a closed paren, and between the 2 parens is where you put the arguments you're feeding to the function. And that's the case here. Okay. So a little bit more about this command. Housing.df is a data frame, and the data frame currently doesn't exist, but it will be created when we read in the file. Read.csv is a function, as I indicated, and it was designed to read and load a CSV file. Now, for those of you who aren't familiar with a CSV file is a comma-separated variable file. A comma-separated variable is basically a flat text file where we didn't put any fancy formatting or anything like that in it. It's just a flat text file, void of all that formatting stuff, and it has commas that are separating all the variables. So that's what CSV stands for. It's a flat file with comma-separated variables, and it's the simplest way to read data into R or into a number of other applications. You can actually read a CSV file into Excel. Excel sort of natively will read that in. All you have to do is indicate that it's the comma that's separating the values, and it works fine. So it's a very common format. So westroxbury.csv is a flat text file, comma-separated variables, and it can be referred to in this manner because it resides in our working directory. Okay, that's an important piece. That'll save you a whole lot of frustration if we cover get working directory and set working directory right away, which we will do next. Okay, the last piece of the command is header equals true. Header equals true is an indicator that we do have a header row in our file that tells us what all of the columns are, and that the read.csv should treat that first row as a header row. The one anomaly that I want to show you is that header is equal to capital TRUE. Booleans in R are treated as capital true and capital false. So you'll need to be clear when you set those that you are in fact using the capitals. All right, a little bit more about some of this. I have told you that we are going to avoid a whole lot of frustration because I am going to tell you exactly how to place the files on your PC so you'll be able to find them. I'm going to post files into each of the modules, and you'll be able to download the files. They'll probably mostly be .csv files. There may be other formats that we use. And you're going to need to put it in the right place, or you're going to need to indicate to R what the right place is. So that's where the command get working directory and set working directory come into play. When you first start R on your PC, it is going to identify a working directory. That is a single directory or a single folder on your PC, and it will look nowhere else but there unless you tell it to. So if you know what that working directory is, the easiest thing for you to do is just to drop the files that I'm going to give you into that working directory and call it good. And that's all you need to do. If you want to put them somewhere else, you can do one of two things. You can change your working directory, or you can specify the path of the destination where the file has gone. Okay, so first thing, like I said, the easiest way is just to find out what your working directory is using the get working directory command, and then put your file there. We'll take a look at this when we cut over to R, and I'll show you how that works. Okay. All right. You already know what a data frame is from your R chapters. So read.csv is a function. I've already talked about functions. Much of R functionality comes from functions, and they look like this. The name of the function with an open paren and a closed paren, and all of your arguments go into what's between those parens. Okay. There's a couple lists down here, a couple of functions listed down here. We have dimension, we have head, we have tail, we have view. I'm not going to go into these in detail until we actually load the data file. So the next thing to do is to go out and load the data file. And we'll start up R. And there is R. Okay. So before I try to load this data file, I am going to want to figure out what the right working directory is. So what is my working directory? So I can do get working directory, and I put the empty parens. That means basically there's no argument I'm sending to the get working directory function. It's just empty. But it won't work if you don't put the parens. And it tells me C:/users Katie Kirstein documents is the name of my working directory. It's my documents directory. And in Windows 10, it could be your document directory, it could be your download directory, it could be wherever. And one thing to watch out for is that when you download these files from Canvas, they'll probably drop, if you're using Windows 10, they'll probably drop into your downloads directory, and you'll need to move them to your working directory, whatever that directory is. Okay? Or you'll need to use a command called set working directory, in which you, in between the parens, specify what you want the working directory to be. And it will look very much like this format. It's just going to be a different directory. You can set working directory, but what I'm going to do is I'm just going to leave it like it is. Okay. The other thing you could do is when you run the read.csv command, in the part where you specify the name of the file in quotes, you could specify the entire path. So it could be C:/users/Katie Kirstein/documents/westroxbury.csv, all in quotes. And that's the name of the file that you're going to load. So it's 3 ways basically to set up the file so that you don't have to chase around and try to figure out where the file is. Okay. Now I have my working directory set, and I know earlier I put the westroxbury.csv file in that working directory, so I'm all set to go. The next thing I'm going to do is I'm actually going to load this file. So remember, the first part of our command was to specify a data frame, housing.df, and we're going to set that equal to the results of read.csv. Okay, now I have to specify my arguments. And as you probably have already figured out, R is super picky about the characters that you use. So west of West Roxbury is in capital letters, and R of West Roxbury is also in capital letters. And I have to specify the .csv, because that is the actual name of the file, westroxbury.csv. and I have to close it out with a quotation mark because we're matching character by character and case by case the entire thing. Okay. The second part, I've got to separate my arguments with a comma, and the second part is to indicate that I do in fact have a header. Equals, and remember it's got to all be capital letters, true. And I close it out with my close parenthesis. If you forget the close parenthesis, good things will not happen. Okay, and you'll have to do the command again. So that's all set up. Housing.df is set equal to read the results of read.csv, where westroxbury.csv is my file name, and header equals true. Hit return, and it says it doesn't really look like it did anything at all. Well, it didn't throw me an error message. So now I can use some other functions to try to figure out what my file looks like. Okay. So the first one is dimension, and there's a shorter version of it. It's dim, and you have to, of course, feed it an argument in parens. And it will tell you that I have 5,802 records and 14 rows. Well, I want to take a look at the first part of the file. So I'm going to use a function called head, open paren, and it's going to show me all 14 columns, the first 6 rows. Okay, so I get to see what those values are. One thing I want to point out, look at the column names. For example, total value. Total value is actually 2 words in our CSV file. And so when it got loaded into R, it dropped a period in there between total and value. And if you want to refer to those columns by themselves, you're going to need to be able to put that period in there. Otherwise, it's not going to know what you're talking about. So just watch for that. RStudio does something similar, and we'll take a look at that when we get there. What if we want to look at the end of the file? Tail gives us the last 6 columns. And what if we want to look at the entire file? There's a function called view. View is a bit anomalous in the same way that we have to capitalize all of true and all of false when we're working with Booleans. View has a bit of a difference in the sense that it is a capital V and then little IEW. So watch for that, because if you don't use the right one, it ain't going to work. So view is a function with an argument, housing.df, and it opens a different window, and it gives us the entire file. We can't see it, of course, because the screen isn't big enough, but it will allow us to scroll across all 14 columns, and then it would allow us to scroll down through all 5,802 records. So that's great. Our file is loaded, and we can look at it, and now we can do all kinds of things with it. We can run things like summary. We can run averages. We can run all kinds of good information to find things out. And in the next module, what we're going to do is we're going to actually run some visualizations on it. We're going to do some plots and some other things, because the second step in doing data mining is not only acquiring data, which is what we've just done. We've just acquired a data file of 5,802 records. But the second step is to look at it and see if there's any problems or challenges with our data set so that we can clean them up before we actually start working with it. All right, I told you I'd show you how to do this in 2 ways. So we're going to do it in the second way, and that is to do it in RStudio. So I'm going to go ahead and open up RStudio. And there it is. Okay, RStudio comes up with some number of quadrants. There's actually 4 quadrants in RStudio, but they'll shut themselves down if they're not needed. So we're going to go ahead and find the quadrant that says import dataset, and there it is, import dataset. We can actually do it over here as well. There's a function that allows us to import data over here as well, but we're going to do it over here. So import dataset, click on that and pull down to, remember I told you that a CSV is a flat text file? Well, that's great, because the first one is from text. It's a text-based file, and that's what we're going to use to load a CSV file. So click on that. And it's going to allow you now to browse for the file. And this is the real advantage. It's a real advantage because it allows us to find the file we want. If we weren't in the right directory, we could go to whatever directory or whatever folder we wanted, whatever allows us to find our file. But in this case, we'll hit roxbury.csv, open it up, and it gives us this screen. And it says, okay, well, here's the name. Now, we could call it West Roxbury. We'll just leave that name the way it is. Heading, yes, there is a heading. Remember, we had to set heading equals to true, so heading is yes. Row names, automatic separators, comma, that's the other thing that we want to watch out for. Everything that we have here is kind of default, and it's kind of what we want. So we don't really have to change anything. So we'll hit import, and bang, it brings our file in, and it does a view for us. So you see down here, West Roxbury is set equal to the results of read.csv, where the file name is westroxbury.csv. Done. Okay, and then it does a view for us and shows us the file. One thing I will point out is total.value. Put the period in there for us also, where we had an empty space. So now if we want to access any part of this, or we want to do anything with this file, we can do the same kind of functions that we had before, and it's called West Roxbury. Well, you know, I don't want to use West Roxbury. I'm used to using housing.df. So I'm going to set this DataFrame to and now I'm set up just like I was before. I've got a data frame that I can use. I prefer that name because it's easier to type than West Roxbury. So now I can do head housing.df, and it gives me the first 6 rows, just like it did before. So it's the same kind of setup, the same kind of commands. And that is how we will load the file. Once you have a file loaded, there'll be a number of other different things that we can do with it. We can actually access these. And if you remember from your data camp modules, you can go into a data frame and you can indicate specific rows and specific columns using the square brackets. So you could look at housing.df followed by square brackets with whatever designation you want. You could zero in on a section of the file, or you can zero in on a single element of the file, or you can look at all of the first 3 rows, whatever you want. We'll practice with that a little bit more in the next video that we do, because I want to go through in the next video how to access specific items in the file. I want to show you how to do specific functions in the file that are mathematically based, and I want to also do some visualization. Okay, until next time.